February 1945. The Siegfried Line, Western Germany. Unteroffizier Klaus Hartwich crouched inside reinforced concrete bunker position 7 kilometers behind the front line. He'd served in fortification artillery observation since 1943, first in Italy, now here defending the Reich's western border. The bunker's walls were 2 meters of reinforced concrete, designed to withstand anything except a direct hit from the heaviest bombs. 7 kilometers back meant protection from American field artillery. Their 105mm guns could harass the front lines, but lacked the range to threaten rear positions. Their 155mm howitzers hit harder, but fired on high arcs with limited accuracy at distance. Standard doctrine placed command posts, supply depots, and reserve positions at this depth specifically because American artillery couldn't reach them effectively. Hartwich had grown accustomed to the rhythm of American bombardments, morning barrages against forward positions, afternoon counter-battery fire, evening harassment. Predictable patterns from predictable ranges. The Americans had numbers, everyone acknowledged that, but German positions built in depth could absorb the punishment. What happened that morning shattered assumptions. Not the ascending whistle of howitzer fire arcing overhead. Something entirely different. A horizontal roar, like a freight train passing at ground level, but impossibly fast. Hartwich's mind registered the wrongness before identifying the source. The shell struck the bunker 200 meters north. The detonation wasn't the sharp crack of 105mm fire, or even the heavier thump of 155mm howitzers. This was something that made the ground convulse. Hartwich felt his teeth rattle. Dust cascaded from the ceiling. The second shell arrived 18 seconds later. Direct hit on Bunker 4. 2 meters of reinforced concrete, designed for protection. The structure collapsed inward. Just gone. Buried everyone inside under tons of rubble. The third shell missed, cratering the road between positions. Hartwich pressed against the wall, trying to make himself smaller. The fourth shell hit their bunker. Not direct, but close enough. The concussion wave felt like being inside a drum someone struck with a sledgehammer. Concrete cracked. Support beams groaned. The radio went dead. Emergency lighting failed. In the darkness, someone was screaming. Maybe Hartwich himself. When the barrage lifted 30 minutes later, 7 bunkers had been destroyed or damaged beyond function. Positions 7 kilometers behind the front line. Outside the range of standard American field artillery. The after-action report filed that evening described it simply, unknown American artillery system, extreme range, heavy caliber, bunker defeating capability. What the Germans had encountered was the M1 155mm gun, known to American gunners as the Long Tom. And over the next 3 months, as Allied forces pushed deeper into Germany, that distinctive acoustic signature from beyond visible range would become the nightmare soundtrack of the Wehrmacht's final defense. American artillery doctrine in World War II emphasized flexibility and rapid fire over extreme range. The M101 105mm howitzer and M114 155mm howitzer formed the backbone of divisional and corps artillery. Both were excellent weapons. The 105mm could put shells on target at 11,000 meters. The 155mm howitzer reached out to 14,600 meters. Experienced crews could deliver devastating fire with impressive accuracy. These guns had proven themselves in North Africa, Sicily, Italy. They supported infantry advances, broke up counterattacks, interdicted supply routes. But as American forces pushed into France following the Normandy breakout, then faced the Siegfried Line fortifications along Germany's western border, limitations became apparent. German defensive doctrine exploited those limitations systematically. Wehrmacht defensive positions were built in depth. Forward observation posts and fighting positions occupied the front line. Behind them, at carefully calculated distances, came command bunkers, artillery positions, supply depots, communications centers, reserve assembly areas. The spacing wasn't arbitrary. German planners knew American artillery ranges precisely. They positioned critical infrastructure just beyond effective reach. The M114 155mm howitzer, firing at maximum elevation, could theoretically reach 14,600 meters. In practice, accuracy degraded significantly beyond 12,000 meters. High-angle fire meant shells descended nearly vertically, making precise targeting difficult. Wind-affected trajectories. Variations in propellant temperature created inconsistencies. At extreme range, the 155mm howitzer could harass and disrupt, but destroying hardened targets required luck more than skill. German fortifications exploited this gap. Reinforced concrete bunkers positioned 13 to 15 kilometers behind the front line remained functionally immune to American divisional artillery. These positions coordinated defensive artillery fire, housed forward observation posts with radio equipment, stored ammunition and supplies, sheltered reserve troops. Destroying them required either aerial bombardment, weather-dependent and often inaccurate, or advancing infantry close enough to assault directly, costly and time-consuming. The problem intensified during the winter of 1944-45. Weather grounded aircraft for days at a time. German positions in the Howitzers quatons, along the Roer River, and throughout the Siegfried Line fortifications presented American forces with bunker complexes they couldn't effectively engage with available artillery. Lieutenant Colonel Bernard Tischendorf commanded a field artillery battalion supporting the 9th Infantry Division during operations along the Roer River in January 1945. His after-action report described the tactical frustration, enemy observation posts clearly visible at 14,000 meters. Reinforced concrete construction. Our 155mm howitzer fire achieved near misses but no destruction. Positions remained operational, directing accurate artillery fire on our forward elements. Infantry assault would require crossing 8,000 meters of open ground under observed fire. Casualties estimated at 40 to 60% before reaching the objective. Air support requested, but weather conditions prevented strikes for 5 consecutive days. Corps artillery included 8-inch howitzers with greater range and destructive power, but these heavy weapons were scarce, difficult to move, and slow to emplace. Getting an 8-inch howitzer into position required extensive preparation. Moving it forward as infantry advanced was cumbersome. The U.S. Army needed something with the destructive power to defeat fortifications, the range to reach deep into German defensive zones, and enough mobility to keep pace with advancing forces. The answer existed, but in limited numbers. The M1 155mm gun, designated the Long Tom by American gunners, had been in development since the 1930s. It was not a howitzer. The distinction mattered enormously. Howitzers fired on high arcs with relatively short barrels. Guns fired on flat trajectories from long barrels, prioritizing velocity and range over arc. The M1 employed a barrel over 7 meters long, compared to less than 4 meters for the M114 howitzer. Both fired 155mm shells, but the similarity ended there. The M1 could reach targets at 23,200 meters, 14 miles. With flat trajectory fire that delivered shells nearly horizontally rather than in steep descending arcs. This fundamentally changed how the weapon engaged targets. Instead of dropping shells from above, the Long Tom punched through fortifications with nearly direct fire. Range, flat trajectory, and heavy 95-pound shells made it uniquely capable of destroying hardened targets that other divisional artillery couldn't touch. But in early 1945, Long Toms remained relatively scarce in the European theater. Production had prioritized howitzers. The guns that did exist were concentrated at Corps and Army level, allocated to specific operations rather than distributed throughout divisional artillery. Most American infantry divisions had never worked with long-tom support. Most German defenders had never experienced it. That was about to change. The M1 155mm gun emerged from interwar artillery development, focused on increasing range without sacrificing mobility. During World War I, both sides employed massive railway guns and static artillery that could strike targets at extreme distances, but these weapons couldn't move with advancing armies. The challenge facing American ordnance designers in the 1930s was creating a gun that combined long range with tactical flexibility. The solution required rethinking basic artillery design. The M1 employed a barrel 7.162 meters long, giving it a length-to-caliber ratio of 45:1. For comparison, the M114 155mm howitzers barrel was 3.76 meters long, a ratio of 23:1. This extended barrel allowed propellant gases to accelerate the projectile for much longer, generating significantly higher muzzle velocity. The M1 achieved 853 meters per second, compared to 563 meters per second for the M114 howitzer. Higher velocity meant flatter trajectory. The M1 fired at maximum elevations between 45 and 65 degrees, depending on the target range, but even at these angles, the shell's flight path remained much flatter than howitzer fire. At 15,000 meters, an M114 howitzer shell climbed to over 3,000 meters altitude before descending. An M1 shell traveling the same distance peaked around 1,200 meters. The difference affected everything from time of flight to impact angle to accuracy. The weapon system consisted of the gun itself, mounted on a split-trail carriage. The trails, two long arms extending behind the gun, spread wide during firing to distribute recoil forces and provide stability. The entire assembly weighed 13,880 kilograms. For transport, the gun separated into two loads, the barrel and recoil mechanism on one carriage, the trails and mounting on another. This made it manageable for long-distance movement, but meant the weapon required more setup time than lighter field pieces. Towing required the M5 high-speed tractor, a tracked vehicle specifically designed for heavy artillery. The tractor could move the gun at speeds up to 35 kilometers per hour on roads, though practical movement rates were slower. Deploying the gun from travel to firing configuration took an experienced crew about 30 minutes. Displacing and relocating took similar time. This was significantly longer than the 10 to 15 minutes required for a 105mm howitzer, but much faster than the hours needed for 8-inch howitzers or larger pieces. The crew numbered 14 men: gun commander, 2 loaders, 2 rammers, 2 ammunition handlers, fuse setter, powder handler, 2 traversing operators, elevation operator, and driver. Each position required specific training. The gun commander directed fire based on coordinates from forward observers or fire direction centers. Loaders handled the 95-pound projectiles. Rammers drove shells into the chamber. The elevation and traversing operators adjusted the gun's aim with precision hand wheels. Coordination between these positions determined the gun's rate of fire. Maximum rate of fire was 2 rounds per minute, though sustained fire rates were closer to 1 round per minute to prevent barrel overheating and crew fatigue. This was slower than the 4 to 6 rounds per minute achievable with the 105mm howitzer, but the M1 wasn't designed for saturation fire. It was a precision instrument for destroying specific high-value targets. Ammunition came in several varieties. The M101 high-explosive shell weighed 95 pounds and contained 15.4 pounds of TNT, or Composition B explosive. Upon impact, this created a crater approximately 6 meters in diameter and 2 meters deep in soft soil. Against concrete, the shell's velocity combined with explosive force to create penetrating power that could defeat fortifications designed to withstand smaller calibers. The M112 armor-piercing shell sacrificed explosive content for a hardened steel body designed to penetrate concrete before detonating. These specialized rounds saw limited use but proved valuable against specific bunker targets. The M110 white phosphorus shell created smoke screens or incendiary effects. The M107 chemical shell, though never employed in Europe, existed in inventory. Propellant charges came in bagged increments, allowing gunners to adjust muzzle velocity based on range to target. Maximum charge generated maximum range, but also maximum wear on the barrel. Minimum charge provided shorter range with less barrel stress. This flexibility allowed the same gun to engage targets from 2,000 to 23,200 meters without changing position. Fire direction required sophisticated calculation. Unlike direct-fire weapons where gunners could see their target, the M1 operated as indirect fire artillery. Forward observers identified targets and radioed coordinates. Fire direction centers calculated the necessary elevation, azimuth, and charge based on target location, gun position, weather conditions, ammunition temperature, barrel wear, and numerous other factors. These calculations involve trigonometry, ballistics tables, and careful measurement. Getting them right meant hitting targets 14 miles away with reasonable accuracy. The M1's flat trajectory provided advantages beyond simple range. Howitzer fire descending at steep angles could be defeated by relatively thin overhead cover. Shells plunging downward at 60 or 70 degrees lacked the horizontal velocity to penetrate thick roofs. The M1's flatter trajectory meant shells struck targets at angles between 30 and 45 degrees, delivering much greater horizontal force. Against bunkers, this meant the shell could penetrate the wall rather than having to defeat the thickest overhead protection. Accuracy at extended range exceeded howitzer capabilities. The flatter trajectory reduced wind drift effects. Higher velocity reduced time of flight, giving atmospheric conditions less time to affect the shell. Experienced crews could consistently place shells within 50 meters of the aiming point at maximum range. Follow-up rounds could adjust based on observation and walk onto the target systematically. But the weapon's most psychologically devastating characteristic was its acoustic signature. Soldiers who experienced M1 fire described it differently than standard artillery. The high-velocity shell created a distinctive noise as it tore through the air. Not the ascending whistle of howitzer fire, but a horizontal roar, like a freight train passing at ground level. Because the trajectory was flatter, there was virtually no warning. With howitzer fire, you heard the ascending whistle, had seconds to take cover, then heard the descending whistle before impact. With the M1, you heard the roar and the impact almost simultaneously. There was no time to react. You either were in cover already or you weren't. German defenders would learn to fear what that thunder meant. Shells arriving from beyond the range they thought was secure. Americans who could reach you anywhere. Before we continue, subscribe to the channel and leave a comment telling me where you're watching from. These are the technical details that explain how battles were actually won. The 155mm gun battalions first saw action in Italy during 1944, though initially in limited numbers. The 191st Field Artillery Battalion deployed to Italy in January 1944, equipped with 12 M1 guns organized into 3 4-gun batteries. Their mission was providing long-range fire support for Fifth Army operations against the Winter Line, and later the Gothic Line. The terrain complicated employment. Italian mountains offered German defenders natural fortifications enhanced with concrete bunkers and artillery positions built into hillsides. Standard field artillery struggled to engage these positions effectively. Howitzers firing uphill lost range. The steep terrain created dead zones where shells couldn't reach. German observers on mountain peaks directed accurate fire on American positions while remaining immune to counter-battery fire. The 191st's first significant engagement came in March 1944 during the Third Battle for Monte Cassino. German positions on the heights overlooked the Liri Valley, preventing Allied advance toward Rome. Preliminary bombardment included massive aerial strikes and concentrated artillery fire, but many German positions survived in reinforced bunkers and cave complexes. Captain Edwin Moretti commanded Battery A. His 4 guns emplaced in olive groves 7 miles from German positions on the mountain slopes. Fire direction calculated elevations accounting for the uphill trajectory. The targets were specific, bunker complexes identified through aerial reconnaissance and forward observer reports. Each gun received coordinates for assigned targets. The barrage began at 0800 hours on March 15th. Unlike the saturation fire from howitzer battalions, the long toms engaged in methodical precision shooting. Fire one round, observe impact, adjust, fire again. Each gun focused on destroying its assigned bunker rather than area saturation. Over 6 hours, Battery A fired 180 rounds, averaging 45 per gun. Post-battle assessment credited the battery with destroying or severely damaging 11 bunker positions. But Italy's terrain limited what the M1 could achieve. Mountains restricted fields of fire. Moving the heavy guns along narrow mountain roads was difficult. The weapons' capabilities were partially wasted on targets that could have been engaged by lighter, more mobile artillery or aircraft when weather permitted. France was different. France was where the Long Tom found its ideal battlefield. Following the Normandy breakout in August 1944, American forces pursued retreating German armies across France toward the German border. The advance moved faster than anticipated. Supply lines stretched thin. Forward units often operated beyond range of supporting artillery. German defenders, falling back on shorter supply lines, could concentrate artillery fire on American spearheads while remaining out of reach of counter-battery fire. The 960th Field Artillery Battalion, equipped with M1 guns, deployed to France in September 1944, attached to 3rd Army. Major Stefan Kowalski, the battalion operations officer, later described their mission. "We were the long arm. When forward observers spotted German artillery positions, supply dumps, command posts beyond the range of divisional howitzers, they called us. Our job was reaching out and eliminating targets nobody else could touch." On September 18, 1944, elements of the 5th Infantry Division encountered heavy resistance near Arnaville along the Moselle River. German artillery positioned on heights east of the river delivered accurate fire on American positions, attempting to expand the bridgehead. The German guns sat approximately 16,000 meters from the river, beyond effective counter-battery range. Forward observer Lieutenant Marcus Silverstein, attached to the 5th Division's lead regiment, identified the German battery positions through smoke and muzzle flashes. He radioed coordinates to the Division Fire Direction Center, which passed the mission to the 960th. Battery C displaced forward, moving within 8,000 meters of the American front line to bring the German positions within range. The 6 guns of Battery C emplaced in a field north of Arnaville at 14:30 hours. Setup took 40 minutes. Fire direction calculated firing data. At 15:15, the battery fired ranging shots. Silverstein observed impacts and radioed corrections. By 15:30, shells were landing within the German battery position. Over the next 30 minutes, Battery C fired 72 rounds. German return fire ceased at 15:45. Prisoners captured 2 days later during the advance confirmed that the American long-range fire had destroyed 3 105mm guns, killed 17 men, and forced the battery to abandon position. A pattern emerged. German defenders positioned artillery, mortars, and command posts at ranges they considered secure based on experience with American divisional artillery. Then the long toms would reach out from distances German planners hadn't accounted for. The psychological effect compounded the tactical impact. German gunners who thought themselves protected discovered they were vulnerable. Rear area positions came under accurate fire. The protective depth that German defensive doctrine relied upon collapsed. By October 1944, word of the American long-range guns spread through Wehrmacht units facing American forces. Tactical instructions began appearing in German orders, emphasizing the need to position critical installations at greater distances from the front line. Intelligence reports attempted to identify the characteristics of the weapon system. Interrogation officers questioned captured American artillerymen about the gun's capabilities and employment. The 258th Field Artillery Battalion supported operations in Lorraine during October and November. Their war diary documented steady employment against targets throughout the German defensive zone. October 12th, counter-battery fire against German 150mm positions, range 18,400 meters. October 19th, disruption of observation post, range 16,200 meters. October 24th, interdiction fire on supply depot, range 21,000 meters. November 3rd, command bunker engagement, range 19,800 meters. Each mission followed similar procedures. Forward observers or reconnaissance elements identified targets. Fire direction centers calculated data. Batteries fired methodically, adjusting based on observation until achieving desired effects. The missions weren't dramatic in execution. Gun crews performed practice drills. Shells fired. Observers reported results. But the cumulative effect was devastating to German defensive capabilities. German forces adapted where possible. Artillery positions included prepared alternate locations, allowing batteries to displace quickly after firing to avoid counter-battery fire. Command posts relocated frequently. Supply operations emphasized dispersion and concealment. But these adaptations consumed time and resources while reducing operational effectiveness. The Long Tom's existence forced changes that weakened German defensive operations, even when the guns weren't actively firing. American artillery officers recognized they'd found a weapon that filled a critical capability gap. The operational requirements that had driven the EM-1's development proved exactly matched to the tactical realities of fighting through German defensive positions. As Allied forces approached Germany's border and the Siegfried Line fortifications, the Long Tom would face its ultimate test. The Siegfried Line, called Westwall by the Germans, represented the ultimate test of American artillery capabilities. Constructed during the late 1930s, the fortification system stretched along Germany's western border from the Netherlands to Switzerland. The line consisted of over 18,000 bunkers, pillboxes, gun emplacements, and observation posts, built from reinforced concrete and positioned across multiple defensive belts. Wehrmacht engineers had designed these positions to exacting standards. Forward pillboxes housing machine guns and anti-tank weapons featured walls 1 to 2 meters thick with steel-reinforced construction. Larger bunkers serving as command posts or troop shelters employed even thicker walls. The fortifications were positioned in networks extending 15 to 20 kilometers deep, creating interlocking fields of fire while exploiting range limitations of enemy artillery. American forces reached the Siegfried Line in September 1944, expecting to breach it quickly before winter. They discovered breaking the fortification line was far more difficult than anticipated. Standard infantry assault tactics stalled against bunkers that machine gun and rifle fire couldn't suppress. Tank guns could damage bunkers but rarely destroyed them completely. Division artillery could harass positions but struggled to achieve decisive effects. The 155mm gun battalions became essential to reducing these positions. The 7 Corps, attacking through the Siegfried Line near Oschan in October 1944, coordinated Long Tom fire with infantry assaults in what became a template for bunker-busting operations. The procedure developed through trial and adjustment. Forward observers or reconnaissance patrols identified specific bunker targets and marked their positions on maps. Fire direction centers calculated firing data based on precise coordinates. The Long Toms engaged from positions 10 to 15 kilometers behind the front line, well beyond German infantry weapons and most artillery. Initial rounds were ranging shots. Forward observers watched the impacts and radioed corrections. Add 100 left 50. Fire direction adjusted the data. The next round landed closer. More corrections. When rounds landed within 25 meters, the observer called fire for effect. All guns in the battery concentrated on the target. The shells struck bunkers at angles between 30 and 45 degrees rather than the steep descent of howitzer fire. The high-velocity impact combined with explosive force created effects that surprised German defenders. Fortifications designed to defeat vertical bombardment proved more vulnerable to near-horizontal strikes. The shells could punch through walls before detonating, creating internal explosions that were catastrophic for anyone inside. Sergeant First Class Otto Brenner, a Wehrmacht engineer who helped construct Siegfried Line fortifications and later defended them, was captured in November 1944. His interrogation report provided German perspective on long-tom effectiveness. The Americans had a gun that fired from very long range with flat trajectory. The shells arrived with little warning. When they hit the bunkers, even heavy bunkers, the walls cracked. Several direct hits would cause collapse. We could not predict when the Americans would target our position. Men refused to stay in bunkers they knew could be destroyed from beyond our artillery range. Better to be in a foxhole that offered concealment than a bunker the Americans could target. The 955th Field Artillery Battalion supported the 1st Infantry Division during November 1944 operations near Eschweiler, northeast of Aachen. German defenders held fortified positions, with particularly strong bunker complexes anchoring their defensive line. Over 8 days, the 955th engaged 47 separate bunker targets. Their after-action report documented the ammunition expenditure: 1,247 rounds fired, averaging 26.5 rounds per target. Post-battle assessment by engineer officers found that bunkers receiving sustained fire from the M1 guns showed systematic destruction patterns. Initial hits created cracks in the concrete. Subsequent impacts exploited those cracks, spalling concrete from the interior walls. Continued fire widened the damage until structural collapse. Bunkers that might have required days of infantry effort to reduce could be destroyed in hours of artillery fire. The psychological effects paralleled the physical destruction. German defenders in the Siegfried Line bunkers had considered their positions secure. When American long-tom fire demonstrated it could reach and destroy these supposedly protected positions, German morale suffered accordingly. Interrogation reports from captured German soldiers in late 1944 repeatedly referenced the long-range American artillery. One report from December 1944 quoted an Oberjefreiter from the 12th Infantry Division. "We were told the bunkers would protect us. American artillery could not reach our rear positions. These things were not true. The Americans fired from such distances we could not see their guns, could not bring our own artillery to bear. The shells came without warning." Men became afraid to occupy the bunkers. When the Americans attacked, we were dispersed in field positions rather than concentrated in prepared defenses. The tactical advantages were substantial. American infantry advancing against Siegfried Line positions could coordinate with long-tom fire in ways impossible with shorter-range artillery. Forward observers with the assault troops could call for fire on bunkers blocking the advance. Because the long-toms fired from such distance, there was minimal risk of short rounds hitting American troops. The flat trajectory meant shells passed well overhead of friendly forces, impacting targets on or near the front line without endangering attackers. Contrast this with howitzer support, where high arc fire created danger zones. Shells ascending from howitzers behind American lines passed directly over friendly troops before descending on targets. Slight miscalculations or defective ammunition could cause short rounds to land among American positions. This risk forced commanders to establish safety distances. The long-tom's flat trajectory eliminated much of this danger. The coordination improved as forward observers gained experience working with the weapon. Lieutenant Aaron Rosenthal, a forward observer attached to the 16th Infantry Regiment during Siegfried Line operations, described the evolution. "Initially, we called for fire like we did with divisional artillery. But we learned the gun's unique capabilities allowed different tactics. We could engage bunkers simultaneously with the infantry assault because the trajectory kept shells well clear of our advancing troops. We could destroy multiple positions in sequence, suppressing one bunker while assault teams maneuvered against another. The Germans couldn't predict which bunker we'd hit next because all of them were vulnerable from a single gun position. By December 1944, long-tom battalions were in high demand throughout 1st and 3rd Armies. Corps commanders requested priority allocation for upcoming operations. Division commanders whose sectors received M1 support planned assaults around the weapon's capabilities. Artillery officers analyzed German defensive positions specifically to identify targets suitable for long-tom engagement. The weapon had proven its worth against Germany's most formidable fixed fortifications. Now the question was whether enough guns existed to meet operational demands as Allied forces prepared for the final push into Germany itself. If you think this level of tactical detail matters, hit subscribe and leave a comment with your thoughts on how artillery shaped the final campaigns. The Wehrmacht wasn't passive in face of American long-range artillery superiority. German artillery officers and defensive planners recognized the threat and attempted countermeasures. Understanding these efforts and why they largely failed reveals how the Long Tom created tactical problems German forces couldn't adequately solve. The most obvious counter to long-range artillery was counter-battery fire. When American guns fired, muzzle flashes revealed their approximate positions. German artillery could theoretically target those positions and suppress or destroy the American batteries. This worked against divisional artillery positioned 3 to 5 kilometers behind American lines. German 105mm and 150mm guns could reach those positions. Forward observers could direct fire. Counter-battery duels were common throughout the campaign. The Long Tom's extended range changed this calculation. M1 batteries positioned 12 to 15 kilometers behind American lines sat beyond the range of most German divisional artillery. The Wehrmacht's standard field guns, the 10.5 centimeter LEEFFH 18 howitzer and 15 centimeter SEFFH 18 howitzer, had maximum ranges of 10,675 meters and 13,325 meters respectively. They couldn't reach the Long Tom positions without advancing or displacing forward, which exposed them to American counter-battery fire from closer divisional artillery. Germany did field longer-range weapons. The 17-centimeter Cannon 18 gun achieved ranges comparable to the M1, reaching 29,600 meters. The 21-centimeter Mercer 18 howitzer threw enormous shells out to 16,700 meters. But these weapons existed in limited numbers and were concentrated at corps or army level, not distributed throughout divisions. By late 1944, Germany was losing artillery faster than production could replace it. The heavy guns were precious assets allocated to critical sectors. Using them for counter-battery missions against American positions meant they weren't available for supporting defensive operations. Even when German heavy artillery could theoretically engage Long Tom positions, actually doing so proved difficult. American batteries employed sophisticated counter-battery techniques. They fired from positions with good overhead concealment, often in tree lines or near buildings that masked muzzle flashes. They used displacement tactics when possible, firing a mission then quickly relocating before German counter-battery fire arrived. They employed meteorological data and precise firing calculations that reduced the number of ranging shots required, minimizing exposure time. American counter-battery radar installations, increasingly common by early 1945, detected German artillery fire and calculated gun positions within minutes. German batteries attempting to engage the Long Toms often found themselves targeted by multiple American artillery battalions before they could complete their fire missions. The artillery duel became asymmetric. American guns could engage German positions while remaining relatively immune to counterfire. German defensive planning adapted by emphasizing dispersion and concealment. Rather than concentrating forces in obvious bunker complexes, units scattered into smaller positions with overhead cover and camouflage. This reduced vulnerability to long-range precision fire, but also degraded defensive effectiveness. Dispersed positions couldn't generate the same concentrated firepower as prepared fortifications. Camouflaged positions hidden from American observers were also harder to coordinate and control. Some German commanders attempted deception. Dummy positions, constructed to resemble bunkers or artillery emplacements, drew American fire away from actual defensive positions. This worked occasionally but required significant engineer effort to construct convincing decoys. American forward observers grew skilled at distinguishing real positions from dummies through sustained observation. A dummy bunker didn't show signs of occupation. It didn't have communications trenches with foot traffic. It didn't show light discipline failures at night. Experienced observers could identify which positions warranted fire and which were decoys. German forces also tried to neutralize American forward observers. If observers couldn't see targets and direct fire, the long toms couldn't engage effectively. German snipers, patrols, and artillery targeted observation posts systematically. This created continuous danger for American forward observers, but couldn't eliminate them entirely. The U.S. Army maintained multiple observation posts, rotated observers regularly, and positioned them defensively with infantry security. Losing an observation post was tactically inconvenient, but strategically acceptable because replacements took over the mission. The fundamental problem German forces faced was American artillery range paired with industrial capacity. The U.S. produced shells in quantities Germany couldn't match. American artillery units fired more rounds in a day than some German divisions had in their entire ammunition allocation. The long tom's precision meant those rounds achieved effects disproportionate to their numbers, but quantity remained available when needed. Colonel Heinrich Voigt, Chief of Artillery for the German 74 Corps defending along the Roa River in February 1945, addressed the problem in a tactical assessment captured after the war. American artillery superiority manifests in three dimensions: quantity of tubes, quantity of ammunition, and range of engagement. We can occasionally match them in quality of equipment and training of personnel. We cannot match their material superiority. Their long-range guns position themselves beyond our ability to respond while engaging our positions with impunity. Countermeasures require resources we do not possess. By February 1945, as Allied forces pushed across the Roa River and began the final drive into Germany, Wehrmacht defensive doctrine had fundamentally changed in response to American artillery superiority. The detailed defensive planning and carefully constructed bunker networks that characterized operations in 1944 gave way to more fluid defenses. German forces occupied positions temporarily, displaced frequently, avoided concentrating in locations vulnerable to observed artillery fire. This adaptation prolonged the war by making German defenses harder to fix and destroy, but it also meant Wehrmacht units were fighting from weaker positions with less coordination. The defensive strength that well-prepared, mutually supporting fortifications provided was sacrificed to reduce vulnerability to long-range precision fires. Either choice carried costs. Lieutenant Friedrich Gottschalk, an artillery officer with the 89th Infantry Division captured near Dusseldorf in March 1945, articulated the dilemma in his interrogation. We could dig positions and prepare defenses, but the Americans would destroy them with long-range fire before we even made contact with their infantry. We could disperse and conceal ourselves, but then we lacked the firepower concentration to stop their attacks. Every option was bad. We could only choose which bad option seemed least terrible for our tactical situation. The Long Tom hadn't single-handedly won the war. No weapon system does that. But it had created a tactical problem German forces couldn't solve, forcing adaptations that weakened defensive capabilities across the board. As winter gave way to spring and Allied armies prepared to cross the Rhine, American long-range guns would accompany every major operation. The 155mm gun battalion's contribution to the final campaigns in Europe extended beyond individual targets destroyed. The weapon's capabilities influenced operational planning at the highest levels and shaped how American commanders conceived assaults against prepared German defenses. By March 1945, the U.S. Army had deployed 18 separate 155mm gun battalions to the European theater, each with 12 guns organized into 3 batteries. This represented 216 weapons distributed among 1st, 3rd, 7th, and 9th armies. Compared to thousands of 105mm and 155mm howitzers, the Long Toms remained numerically limited. but their operational impact far exceeded their numbers. Corps and Army commanders allocated long tom battalions to support specific operations where their unique capabilities proved essential. The Rhine River crossings in March 1945 exemplified this employment. Crossing a major river against defended positions represented one of warfare's most difficult operations. German defenders on the east bank could observe American preparations, concentrate artillery fire on crossing sites, and position reserves to counterattack bridgeheads. Successfully establishing and expanding bridgeheads required suppressing German positions beyond the river while American forces were at their most vulnerable. The 258th Field Artillery Battalion supported 7 Corps Rhine crossing at Remagen on March 7th. When advance elements of the 9th Armored Division discovered the Ludendorff Bridge still intact, seizing it became an immediate priority. German defenders controlled positions on heights east of the river that could bring devastating fire on the bridge and any forces crossing it. The 258th, positioned west of the river, engaged these German positions systematically. Over the first 36 hours after the bridge's capture, the battalion fired 847 rounds at German bunkers, artillery positions, and assembly areas identified through air reconnaissance and forward observer reports. The German positions sat 15 to 18 kilometers from the American guns, beyond range of divisional artillery, but well within the M1's capabilities. Neutralizing these positions before German forces could organize coordinated counterattacks against the bridgehead proved crucial to the crossing's success. First Army's after-action report for the Remagen operation specifically credited long-range artillery support with enabling the bridgehead's rapid expansion. Enemy positions that would normally require days of reduction through infantry assault or aerial bombardment were neutralized within hours by precision artillery fire. This allowed bridgehead forces to consolidate and expand against reduced resistance, denying the enemy time to organize effective countermeasures. The Rhine crossings by 3rd and 9th Armies later in March employed similar tactics. Long tom battalions received priority targeting against German positions critical to the crossing's success. Fire direction centers coordinated with air reconnaissance and signals intelligence to identify high-value targets. Command posts coordinating defensive fire, artillery positions engaging the crossing sites, ammunition dumps, and communications centers. The operational flexibility this created allowed American commanders to plan crossings with confidence that German positions would be suppressed. Previous amphibious and river crossing operations had required accepting that enemy positions beyond artillery range would remain functional until infantry could advance close enough for divisional artillery to engage them. The long tom eliminated this limitation for targets within 23 kilometers. Beyond specific operations, the weapon's existence influenced German defensive planning throughout the final months. Intelligence officers analyzing captured German documents found repeated references to American long-range artillery capabilities. Defensive plans incorporated greater depth, dispersed critical installations across wider areas, and emphasized mobility over static positions. These adaptations degraded defensive effectiveness and consumed resources Germany couldn't spare. Stories like this deserve to be remembered with precision and respect. Subscribe and leave a comment telling me what other untold stories you want to hear. The psychological impact manifested in multiple ways. German soldiers interviewed after the war frequently mentioned American artillery superiority as a primary factor affecting morale. Quantity, quality, and range created a persistent sense that nowhere offered true security. Forward positions faced divisional artillery. Rear positions faced the long toms. Areas beyond even the M1's range could be struck by aircraft when weather permitted. The Wehrmacht's ability to provide its soldiers with secure positions from which to fight eroded continuously. American artillery officers, meanwhile, incorporated the long tom into their tactical doctrine with enthusiasm. Field Artillery School training emphasized coordinating divisional howitzers with corps-level gun battalions to create layered fires covering shallow, medium, and deep targets. Forward observers learned techniques specific to directing long-range precision fire. Fire direction centers developed procedures for calculating firing data that accounted for the M1's unique ballistics. After Germany's surrender in May 1945, analysis of the weapon's combat record showed the 18 battalions had collectively fired approximately 310,000 rounds during operations from September 1944 through May 1945. Targets engaged included an estimated 2,400 bunkers and fortified positions, 890 artillery battery positions, 340 command posts, and countless area targets. The ammunition expenditure averaged 17,200 rounds per battalion over 9 months of operations, with individual battalions firing significantly more during intense periods. Production records show the United States manufactured 2,944 M1 guns between 1938 and 1945. Many remained in the United States for training or coastal defense. Others deployed to the Pacific Theater, though jungle terrain and island warfare offered fewer opportunities to exploit the weapon's range compared to European operations. The concentration of 216 guns in Europe represented a conscious allocation decision prioritizing the theater where the weapon's capabilities best matched operational requirements. The M1 remained in American service through the Korean War, where it again provided long-range fire support. Modernization programs updated the carriage and fire control systems, but the basic gun design remained unchanged. It wasn't until the 1950s that newer weapons like the M109 self-propelled howitzer with improved range finally began replacing the long tom in frontline units. For the German defenders who experienced the weapon's effects during 1944 to 45, the memory remained vivid. That distinctive acoustic signature, the horizontal roar from beyond visible range, the knowledge that American gunners could reach positions that were supposed to be secure, the concrete bunkers designed for protection collapsing under sustained precision fire. The long tom represented more than effective artillery. It exemplified the American approach to warfare in World War II, identifying problems through combat experience, developing technical solutions that leveraged industrial capacity and engineering expertise, then deploying those solutions in numbers sufficient to achieve operational effects. The Wehrmacht couldn't match this cycle. German engineers designed effective weapons, but industry couldn't produce them in adequate quantities, and operational realities prevented concentrating them where needed most. The 155mm gun battalions weren't glamorous. They didn't capture headlines like tank battles or infantry assaults. The crews who served them spent the war positioned kilometers behind the front lines, rarely seeing the targets they destroyed or the enemy soldiers they killed. But their contribution to victory was undeniable. Every bunker destroyed by long-range fire was a bunker infantry didn't have to assault. Every German artillery position neutralized was a position that couldn't shell American troops. Every command post demolished by precision strikes was a headquarters that couldn't coordinate defensive operations. Sergeant Thomas Ruska served as a gun commander with the 987 Field Artillery Battalion from October 1944 through the end of the war. His account, recorded in 1983, captured what the work meant to those who did it. We fired the gun based on coordinates radioed from observers we never met. We aimed at targets we never saw. We never knew specifically what we hit or who we killed, but we knew what we were doing mattered. When the forward observers called for fire, it meant Americans were in contact, taking casualties, needing support. When we put rounds on target, we were helping them. That was enough. We did our job. We fired the gun. The technical specifications tell part of the story. The M1 155mm gun fired a 95-pound shell 23,200 meters with accuracy sufficient to destroy bunkers and neutralize artillery positions. But understanding its impact requires understanding the human context. German soldiers who felt terror when they heard that distinctive roar. American forward observers who knew they could call for fire that would actually reach and destroy the targets threatening their infantry. Artillery crews who worked with precision and dedication to support soldiers they would never meet. The Germans understood what they faced. By early 1945, captured documents and interrogation reports show Wehrmacht intelligence had identified the M1 and analyzed its capabilities. German defensive planning incorporated this knowledge. But knowing the threat and countering it effectively were different challenges. Germany lacked the industrial capacity to produce equivalent weapons in sufficient numbers. They lacked the ammunition stockpiles to engage in sustained counter-battery duels. They lacked the observation capability to identify and target American positions effectively. And critically, they lacked the air superiority necessary to strike American artillery positions from the air. The Long Tom didn't exist in isolation. It was one component of an artillery system that included forward observers with radios, fire direction centers with trained personnel and calculating equipment, logistics networks delivering ammunition, meteorological services providing weather data for ballistic calculations, counter-battery radar detecting enemy fire, and air superiority preventing enemy air strikes on gun positions. Every element had to function properly for the weapon to achieve its potential. The U.S. Army had built this system systematically. Training programs at Fort Sill and other artillery schools taught forward observers, fire direction specialists, and gun crews the specific skills their positions required. Communications networks provided reliable radios and established procedures. Logistics organizations delivered ammunition to batteries, even during rapid advances. The technical services provided maintenance support and spare parts. Intelligence analyzed enemy dispositions and identified targets. Everything interconnected. This systematic approach to warfare, building integrated systems rather than merely deploying individual weapons, represented perhaps the deepest difference between American and German operational methods by 1945. Germany still fielded technically impressive weapons, sometimes superior to American equivalents in specific characteristics. But German forces couldn't integrate their weapons into systems that functioned reliably under the chaos and pressure of combat. Supply failures, communications breakdowns, lack of trained personnel, inadequate maintenance, and loss of air superiority degraded German effectiveness regardless of weapon quality. The M1 155mm gun, firing from positions carefully chosen and prepared, directed by trained observers using reliable communications, supplied with adequate ammunition delivered by organized logistics, protected from counter-battery fire by American air superiority and counter-battery radar, represented this systematic advantage made concrete. Each shell that crashed into a German bunker from 14 miles away carried the weight of American industrial, organizational, and technological superiority. For the German defenders in those bunkers, watching their positions collapse under sustained precision fire, this meant the war was lost. Not because of this weapon specifically, but because of what it represented. An enemy who could solve problems, produce solutions, and deploy them effectively. An enemy with resources to spare. An enemy who kept getting stronger while Germany weakened. That horizontal thunder became the soundtrack of defeat. That's what Unteroffizier Klaus Hartwich heard in February 1945, crouched in his bunker 7 kilometers behind the front line in a position that was supposed to be secure. That's what thousands of German soldiers heard in the final months as Allied forces pushed deeper into Germany. That's what the Long Tom delivered, not just high-explosive shells, but the message that there was nowhere beyond American reach, no position immune from American fires, no depth great enough to provide security. The war ended on May 8, 1945. The guns fell silent. The crews of the 155mm gun battalions stood down from their firing positions. Some units remained in Europe as occupation forces. Others redeployed to the Pacific, though Japan's surrender in August made their combat employment unnecessary. The M1s that had punched through Siegfried Line bunkers from 14 miles away were parked in motor pools, cleaned and preserved. But the men who'd served them, and the men who'd faced them, carried the memory forward. The specific acoustic signature of the shells, the sight of bunkers collapsing, the knowledge that American ingenuity and industrial might had created weapons that changed the battlefield. That's the legacy, the technical achievement combined with the human impact of technology applied to warfare's brutal mathematics.